Guys, hi guys. Good afternoon. First of all, after a long time, we are going to have the class offline. Okay, not online. So it's switching. You guys know what? You guys know routing and switching. We are doing CCNA routing and switching. So what is routing? An idea? Router, routing. Perfect. Any other? In a single word, you can tell what is router. A best part. Best part to reach the destination. In a single word, what is router? There is a word I said every time. There is a word. What is a router? Okay, but I need a perfect name. Name itself it is there. Even every time I used to tell that word. What is router? Gateway. Right? The single word itself you can get a complete meaning. What is router? Name itself is a gateway. So you can send multiple traffics, okay, over the router, but it should be the route should be there. Then only it allows the path means the routes inside the router, inside the organization wherever it is. So it works as like what is security. You can tell us security. In router security will be there, right? So in a gateway security will be there. Likewise, it work as like a security. Where the interface work as security. So who want to go inside, whether he have proper address or not. For example, if there is an apartment, you want to know which apartment, which house you want to go. Then only the security will allow. First thing. Likewise, the router, the routes we receiving from that other devices should need to have what's the destination. Okay, that's very much important. So we can simply call as a gateway. It also forwards and receives traffics. Okay, but uh, different interfaces will have different networks, not the same network. It's very important because while you configuring network, for example, a router has a two interface. The two interface won't have a same network. It's a different network. Okay, understood? So here it's something different. Okay, one more thing about router. Router breaks the broadcast domain. It means it don't have broadcast domain. It breaks the broadcast domain. Broadcast means it sends to everyone. Okay, sends and receives to everyone. It avoids the broadcast domain. And if that's a layer 3 protocol. Okay, and here if you go for a switching, and one more thing, router uses packets. Okay, and here switching is a layer 2 device. It uses frames. Okay, it uses frames, and also it avoids a collision domain. What's the collision symbol? Where is the collision? Collision means, for example, if you have traffic, a huge traffic is there, that's we call as a collision. We can't able to move anywhere because all the routes are covered. The traffic will be not flow to other device, other ports and all. The reason is if there is a collision, like multiple loops are start happening. Okay, to avoid this, we have a switches which avoids a collision domain. Okay, and also it has a broadcast domain. Okay, it will do broadcast. Switches will do broadcast. For example, if your packets or if a frame comes to the port 1 first port, it sent to all other ports as well, because it start broadcasting to the device, into the device going host which is connected to the device first of all. Okay, so that's why we go for switching. Initially we saw routing. Here this switching, this is a layer 2 device. It uses MAC address. Okay, packet IP address are used by routers. Layer 3 protocol. Here it is a layer 2 protocol. What is that? Data link layer which uses MAC address. Understood? MAC what? Sorry? Yeah, source MAC destination we can use. Okay. So first we'll start with the switching. Routes with switch is a switching. Okay. So we'll see one by one as you guys know all these things, but again we'll start from the basics. Okay, so Ethernet, this is a technology. Actually, this Ethernet is it's a first of all it's a technology. So nowadays we see, right, LAN port. Where is it? This side it is a LAN port. So this LAN port is a Ethernet technology. Okay, depends on the speed of the port, it may differ. Okay, so you can see a technology originated by a University of Hawaii. First of all, it was originated by University of Hawaii. First of all, Later, it is adopted by the Xerox Corporation. There is a company called Xerox Corporation. Okay. So, and after that, Ethernet is the most popular physical layer LAN technology. Okay. Anyhow, it's a physical device first of all. Ethernet we use in switching and all. It's fine. After physical layer, we go for a switching, right? Switching need to know which physical layer I'm using. So for that, Ethernet is a technology. Okay, next is like Ethernet standard is known for every, you know, right? Cisco proprietary is there, IEEE standard is there. Okay, so for IEEE standard, every devices, every protocol, sorry, every physical devices will have a standard value. So for this IEEE standard is 802.3. Okay, for example, 802.1q is there. That is for something QAs we can call. ISL QAs is there. That's we can see in the VLAN, VTP and all. We can see that one. So likewise, everything in it this comes in Ethernet will comes in IEEE standard 802.3. Okay, even wireless also will have a standard. Okay, so next is it has a speed of Ethernet will have a speed of 10 Mbps. This you know guys, right? Then later there are different types. Initially it started as a Ethernet. Okay, you can see when the computers invented, only the computers will be like this much room size, but it has only MBs of storage, only MBs of storage, 2 MB, 3 MB of storage. Okay, because there is no much traffic over there that time. But that time it was a 10 MB, it's a higher one. But now what happened? Even we are using mobile, how much speed it is? More than 2 Gbps. So 2 Mbps, 3 Mbps we are using. It depends on the devices we are using, the evaluation started. Okay, so Ethernet, then fast Ethernet, then Gigabit Ethernet. Again, you can have 10 gig ports. You can call it the 10 gig ports. Okay. So for we saw fast Ethernet. Next is a fast Ethernet. So same. As you can see, with the fast Ethernet will also has a IEEE standard, which is 802.3. Here we can see it's 802.3, but it's a 3U. Okay, this is a IEEE standard for fast Ethernet. Okay, and you can see it is established for Ethernet networks that need high transmission speed. Okay, so what is the fast for this? 100 Mbps. That is 10 Mbps. Later we come with the 100 Mbps. Okay, depends on the speed. Again again we come with the Gigabit port. We can call it a Gigabit port as well. We can call Gigabit Ethernet, we can tell, but in a short way we can tell Gigabit port. Okay, Gigabit port was developed for a faster communication network with applications such as multimedia, voice over internet. You guys know now after evaluation we uses multiple multimedia device applications. VoIP, you guys don't know, I think VoIP. VoIP means voice over IP, voice over internet also we can tell. Okay, it means nowadays we know initially we have landline phones, right? Initially we will have landline phones. For every home we'll have a separate cable from BSNL, MTNL. They will get separate cables. But nowadays we can't see that. The reason is it comes over the internet. In Ethernet line itself, we can see in BSNL also, if you get a Wi-Fi device, Wi-Fi connection to your home, they will provide a free landline, and it comes from your Wi-Fi device itself. Understood? It means voice over internet. It's also can call as IP, internet protocol. Same. Voice over internet or internet protocol. Same. And for these and all, it needs some good speed. That's the reason there is an evolution of Gigabit port Ethernet. Okay, so for this also we have a standard 802.3 AB, and after that optimal fiber. You know fiber, right? Fiber communication. Fiber also there. Initially I said for this fiber also we have a means IEEE standard 802.3Z. Understood? Actually, this is not very much important for you guys to remember, but still, just take note of it. Okay. This anyhow, this will I will provide you the PPTs. You can see. Okay, you can download it. Okay, and after that you can see how much speed it has. 1000 Gbps, which means 1 Gbps. Okay, so 1 Mbps means kbps. So 1 GB means 1024 Mbps. Okay, so 1 Gbps means 1000, approximately 1000 Mbps. Okay. So 10 gigabit ports. This is actually a faster one. We use this in almost like in data centers and all. The reason is which can carry multiple applications. So for example, you have your Gmail and all. You have store so many data. Even I have 2 3 accounts. You guys will do have 2 3 accounts. So in all over the world, how many people are there? So all the applications will be goes to your data center at last. Okay, it has a huge traffic if you are start accessing. So for that you need a huge speed of as well to carry your data. So after gigabit port, we have a 10 gig port, 10 gig port, 10 gigabit port. Ethernet. Okay, so you can see 10 gigabit port is fast and most recent Ethernet standard IEEE 802.3AE. Okay, and 10 gigabit ports, sorry, Ethernet is based entirely on the option of fiber communication. It completely based on fiber, not on a uh, what is it? Cat 6 cable, UTP cable. It's not based on the Cat 6. It's based on the purely on fiber because this much speed only carried by fiber, not by Ethernet cable. Okay, or Cat 6 cable or UTP cable. You can tell anyway. Okay, and gigabit port has a speed of 1000 Mbps. It means 10 gigabit speed. Sorry, 10,000. Okay, it means I mentioned wrong word. It's a 10,000, 1000 given typed, but it's a 10,000. Yeah, 10,000 Mbps. It means 10 Gbps. Okay, done. Okay, so it's all basic actually. Why I'm telling is this very important when you guys are going for switching because in your switches will have a Ethernet port, fast Ethernet port, gigabit Ethernet port. Depends on the speed and it depends on the bandwidth required by customer. We need to install the switches. Okay, and for example, your customer will need 10 Mbps speed, but you install certain 100 Mbps speed. You installed a switch which has Ethernet means it won't support more than 10 Mbps. First of all, so no use. Depends. We need to know what the customer need. For example, 100 Mbps customer want, but you don't want to perfectly go for 100 Mbps. You want to go more than that. If tomorrow, if there is some upgrade, customer is going for some 1 Gbps, then it won't support. Even if you go for a device which has already has a 1 Gbps, it will support 100 Gbps, also 1 Gbps. Understood? Okay. Next is a broadcast domain. So you guys know already what is it? Uh, Switches will support the broadcast domain. So what is the work of broadcast domain? One to many, not many, one to all. We can tell one host will send to all. It means so all the ports will start broadcasting. It means there might be a possibility of looping. Again and again I'm sending the same data to the other device. It might be started looping. That's why there is a something some technology came in switching which is called as a STP, spanning tree protocol. Also there is something called as a virtual LAN. So anyhow switches will be used in a LAN networks. Okay, switches used in a LAN networks because for example this is a BSET. So here internally we have devices. For example, if it is connected to the cables and all, so for this we need a LAN connection which is done by switches, not by routers. Okay, because why we go for switches is switches will broadcast. That's the reason we go for a switching. Understood? And okay, so that's the reason we go for switches. That's a layer 2 and it works on MAC address, no need of IP address. Okay, so here broadcast domain is a what I mentioned. Yeah, set. Yeah, perfect. Actually, I forgot that word. Okay, set of network devices for which a broadcast frame is sent by one device is received by other devices in the LAN segment. So first of all, the work of LAN segment is want to send data to the all the devices. Okay, if it is a internet, then we want to tell which device I want to access and which port means. For example, you say FTP or HTTP, which I want to do, we want to mention. But if it is with type of IP address, but if it is a LAN, I don't want IP address. But still, if it is structured, we can go ahead. But if it moreover, we don't need IP address because it works on layer 2 data link layer where we need only MAC address. Understood? So that's the reason you can see this is an example. What is there in the diagram? So initially between the what is the PCs we have one device, right? So that is a switch. Okay, a switch. So if, for example, if something what to say? Wait a minute. For example, here something if I giving means forwarding something here from here to the switch. So what happened is switch will start sending to this device and this device. The reason is it start broadcasting. Okay. Anyhow, you guys know what is broadcast. Anyhow, a TV we will say it is started broadcasting in TV. It means it will send to everyone, even radio broadcast. Everything is broadcast. It means it's not like if it has the same some set of range, it will broadcast to everyone. Likewise, here it broadcast means it will send via all the ports. Switches send broadcast via all the ports, so everyone which is connected will receive the data. Understood? So next, so collision domain. Again, the major advantage in means in the switches is it avoids a collision domain. So how it works? Yeah, collision domain is a set of network devices for which frame set sent by one device could result in a collision with a frame sent by other devices in a same LAN segment. So if again same what is it? For example, I have 24 ports. Example, we have 24 port switches. All the ports will start sharing the device means information to the other device, means all the other 23 ports. It means it started collision. All started sending the traffic in different ports. It means like a junction, right? Traffic junction. All will stuck in the same place. So that's the reason for avoiding the collision domain we have a switches. So where if one gets failed, it is sent through the other one. Understood? We'll go next. There are something in switches. There are some type of switches. Okay, there are two types of switches out there. One is a, I think initially we said all these things, but still, there is two types of switches. One is a manageable, and another one is an unmanageable switch. So, what is manageable and unmanageable? First of all, you guys know OSI layers, right? Layer 1, layer 2, layer 3, layer 4. So, what is the work of layer 2? Data link layer. Data link layer. So, data link layer work on MAC address. Layer 3? IP address. Also, it works on MAC address as well because it works on physical and data link layer, then with the what is it? Network layer. Third layer will works on all the three layers. Okay, with all the three layers, it means it will manage with the help of IP address. So if a switch which is manageable, it means which has a console port where we can configure the device port numbers with some IPs and all. So we can configure, and also the switch will work also as a router. Switch also as a router. So that is called as a manageable switch. Understood? If it is unmanageable switch, it won't has a console port. You guys know what is console port, right? Okay, so console port, there are two types of port initially. One is a no, that console port, and another one is yeah, that's what console port, auxiliary port. Two ports are there. If you are there near to your means device, and you first, for example, initially if you are configuring a device, first new switch, I can tell new switch or new router, you want to connect with your PC with the console port. It's a management port. Okay, there is something called as an there is something called as management plane, control plane, data plane. This is actually a topics in firewall, but why I'm telling is management plane is will helps to log into the device and take full control of the device. First of all, that's the work of management plane. Okay, and second is a control plane. So what the devices need to do will be done in control plane. For example, you are doing routing, right? Routing protocols. What are the protocols you are using? Which path you need to select? All this thing will be comes under control plane. Okay, if you go for a data plane, other things will be done in the data plane. Okay, so likewise the console port is called also a management plane. via that you can configure initially and you take the complete device login. For example, you can even if you connect with the console, you can configure the full device. If something, for example, I'm sitting here, okay, I'm remotely connecting with the device which is connected anywhere, okay. But if something goes wrong, I'm unable to take login. Something like if device is connected, if configuration is gone, that time the only thing we can do is someone go to the physically near to the device and they want to connect with the console port and they want to log in. Okay, even they are unable to access anything, then we can't. That's the last option we want to do. Okay, it's a console. This is the work of console port. Okay, if the device which has a console port, which means it has a management access. So that is called as a management switch. If the device which don't have a console port, okay, then it's an unmanageable switch. Okay, even example for unmanageable switches are like switch is there, unmanageable switch already is there, but we have hub, right? Hub, you know hub, right? Hub bridge. These are all comes in unmanageable, which don't have management port, means console port. And auxiliary port is something different. It's like it's like we can remotely configure, but the auxiliary port will be connected to internet, and internet will be connected also with the internet. So it's straight away not connected with any other ports, only with auxiliary port. Understood? So it's also like a management port, but it's something different, but we can do from a remote. But for console, we need to be there. Physically, physical appearance is required for the console port. So if it is, you can see on a management switch, an IP address can be assigned, configured, so configuration can be made. It has a console port. Okay, and second is unmanageable switch. On an unmanageable switch, configuration cannot be made. We can't able to configure. The reason is we don't have management port, means console port. Okay, and an IP address cannot be assigned and there is no console port. Understood? Got it? So you go for next. So campus network. So it's also very important. So how we classified the networks. For example, if we have an organization, how we classify the devices which are there in our organization. So for example, you can see campus is a learn network supporting layer, supporting larger buildings and multiple buildings close to a specific area. For example, your organization is connected with some data centers. So from there, how the layers we classified, we can tell that as a this one is campus network. So we can see the Cisco user terms to describe the roles of which switch in a campus design. So first of all, there are three layers: access layer, distribution layer, core layer. Already I said this in a thing some few class back. So what is the work is like now in an organization, you guys have basic switches are there, right? So those are called as an access layer. So next level, if you go for router, your organization will have some routers, some high-end routers. So those are called as a distribution layer. If you next level, it goes to data center or to the service provider. So those are all called as core layer, because from the core itself we are getting everything. Okay, that we have next slide for that as well. You can see how the distribution layer is classified. So the switches, PC, everything comes in an access layer. Even you can configure the VLANs. Okay, we'll see that VLAN. In that we have an access layer, access and trunk. We can tell two types. That time you can understood what is that. Access means end devices. Okay, this is all end devices almost in a organization. So those comes under access layer. For distribution layer, you can see all these are connected with some routers and all. So which comes under distribution layer. From there, some high-end devices, maybe it's a data center, so or in a telco devices. So those are all comes in core layer. This is an architecture. This is a hierarchy actually. Okay, hierarchy is how your organization will have their devices. Okay, so core is very much important. From there you will get all your data. For example, the servers, everything will be connected with, means high-end routers, means data center will have all these, right? Even you have firewalls, routers, switches, servers, what's that? We have few devices, load balancers, so many things are there. Even cloud, everything is there connected with your data center. So those all comes in core layer. Next level is after it comes from the data center and all, your organization will have a router, gateway, right? So those and all comes in distribution layer. From there, high-end device, you have switches, PCs, Wi-Fi devices, all these comes in access layers. Understood? So we can see what are the devices in a hierarchy we have in a switch, access layer, distribution layer and core layer. So we have switch series of 1900, 2950, 2960. These are all examples. These are examples. Okay, perfectly it's there, but still we have more devices. Okay, and next we go for distribution layer. We know that switch series of fixed and modular. Okay, initially I think you guys know fixed and modular what I say. You know about what is fixed and modular routers? Routers, switches, fixed and modular. No, right? So fixed routers are like that. There are some ports. For example, there is some 24 ports in a switch. So these ports won't be changed. It's a fixed one. We can't able to change. But if you go from modular, for example, I have 24 ports, but I have some 8 to 10 empty ports. Example I'm telling. Empty ports. Future I need some ports. It means I can add some ports over there. Okay, and I can use that one. So these are all the fixed and modular routers and switches. Okay, these are the series actually. You can see switches series. So 3550, 3560, 3570 are the switches, not routers. Okay, and you can see modular routers starts from 4000 series, 4500 and 5500. And if you go for core switches, you can see the series of 6500. Okay, and nowadays we have some extended new technologies. I think even I am also learning that one. There is something called as Nexus switches. Nexus 1K, 3K, 5K, 7K. These all means thousands. 1K means 1000. 3K means 3000, 5K means 5000, 7K means 7000. These are like very high-end switches. Example, you can manage everything with the help of the switches. It can also work as a router, also a switch. So now this has a something like advanced technology in the means Cisco. But in Juniper and all, it's already there. That has a different series numbers are different. Okay, there if we go for Juniper and all, we can tell SRX 500M, 500MX. So we have some series. But here in Cisco, we have a Nexus switches. So those all comes in a core layer. Even for high speed data and all, we can use the Nexus switches. Understood? So we'll go next. So how we do initial configuration of a switch. You guys know what we are doing in the routers almost same. Till you starts from enable router, configuration terminal, then you configure interface. You will check the interface and you can configure interface. If it is required, we can configure IP address. Okay, all the same. But inside what the protocols we are using, it's different. Okay, almost the same. For example, 20-30% same. Other things is different because it uses switching MAC address, not IP address. But if you go for layer 3 switch, it uses IP address. Okay, that also we can see how we use IP address in the switches. For that also we have different commands. Okay. So and few more means topics are there. It's very basic but very much important. Okay, initially I about to tell this in our routing, but I forgot this. There is something called duplex. Okay, so you can see the switch sends information to the end devices. Vice versa means from up and down, transmitting, receiving. So vice versa, if you are receiving, so that is called as a duplex. So which has some speed, some latency and all. So there is two types of duplex settings are there. One is a full duplex, another one is a half duplex. So and we also call it a simplex. Simplex, half duplex, full duplex. So what is the work? Initially it starts from simplex. Ports will have simplex. Then it came for half duplex, and if it go for full duplex. But what happened is, if you are configuring two devices, okay, switches with a different duplex, it won't work. Okay, for example, one end it has a full duplex, one end it has a half duplex. It means we have some issues. We will get some issues. For example, if you have one end half duplex, other end also you need to have half duplex. If you have full duplex, other end also you need to have full duplex. The reason is the how it works is the main reason. Wait, I'll tell you. Full duplex we can call it as an FDX. Okay, and switches allows for a simultaneous transmission of information between switches and the endpoints. Okay, so how it works we can see next one. We can see in client computer is there and server is there. For simplex means it's a one-way communication. It's sent from client to server. Okay, that's called simplex. So if you go for half duplex, it will do both the communication, but not at the same time. First of all, it's sent, then it will receive. It will wait till the receiver will receive, then again it will get the acknowledgement, means acknowledgement or update. Okay, but if you go full duplex, at the same time will send and receive data. Understood? For example, you can see, I will tell you example. So, simplex, you can take it as a railway track. Okay, in a single railway track, first from host to destination, it will reach. Okay, then if you go for a half duplex, we can know that every day we'll have, for example, local trains will have, it will go and it will come back. Okay, but at the same time, it will go and go. Okay, wait, same. Okay, but for example, if it is full duplex, we have multiple tracks. Both will happen at the same time for source and destination. So that we can call as a full duplex. Okay, now we got it. And for that also we have some speed. Okay, that we can see next slide. You can see duplex and speed. So switches automatically adjust duplex mode. Okay, and speed depends upon the remote device and how much device distance it's covering. Okay, and we can set duplex mode and speed to match the supported modes. Okay, it need to support in the both the devices. For example, some devices will support only half duplex. Okay, but you can't configure full duplex. If both the devices in different location, one will support half duplex, one will support full duplex. It means there might be a issue for a long time. Even in our organization, what happened is we have a setup in our devices. There is something called NAD devices. So where there will have some issues. For example, I am able to properly connect. It is links are continuously flapping. You know flapping, right? It is not a stable. Frequently it get disconnecting. It is called as a flapping or unstable. Okay. So what happened is we will inform the service provider because it's connected with the service provider. If it is a Vodafone, Airtel, AT&T, whatever it is, what we will check is we want to check the speed on the other end, also the duplex settings. Okay, and which we can tell is something called as negotiation. Okay, that is not required here, but still, as an organization setup, I can tell you, negotiation also like it should be auto. Okay, it's not like it want to be set in a same speed. Okay, so that is it's not there in your syllabus, but I'm telling. So it should be same on both, then only start communicating. Understood? So for that we need to have both in same set of devices to communicate. For example, that's what one end I have 10 Mbps device, one end I have 100 Mbps device, but I need only 100 Mbps speed. Means how can the other device will send me that 100 Mbps speed? It's not possible, right? So that's the reason we need to have both in same devices to have perfect speed, duplex, latency, everything. Understood? So this is the configuration. So this is basic configuration. First of all, interface. What is the interface type? Ethernet, Gigabit Ethernet, Fast Ethernet. So those all comes in interface type. Then interface will have a number, say like something like 0/0/0. So this is the interface type. Then it depends on the speed. So how much speed do you want? For example, we can set the speed. I don't want to go more than 100 Mbps, so I can set the speed as speed 100, 1000. And auto also speed means it automatically takes the speed. We can go for that one. For example, if future we are changing the speed, I don't want to change the configuration. And you can see next is like For that is for speed, first one. Next is for duplex. Again interface type, interface number, then duplex. Whether it's a half duplex or full duplex. Now simplex is not there anyhow because one-way communication why we want. And if we want two-way communication, but on anyhow, moreover, 99.9% they will use full duplex. Why they want to wait for half duplex for long time till we get update? So we'll go for a full duplex. Understood? That's it for today.